In this tutorial, we'll be detecting multiple objects within a noisy image. Once completing this tutorial, we've finished every tool that we need in order to automate Where's Wally. In this tutorial, we'll be dealing with an image that's been corrupted by noise, so our template won't match perfectly, and we'll expect this to happen with Where's Wally and in real life with any real problem. We will also be searching for multiple targets. In a Where's Wally puzzle, there are many Wally lookalikes, so the top result might not be Wally. We're going to handle this by returning multiple results, so that we can have some confidence that one of these is the true Wally, and the rest are Wally lookalike. In this tutorial, we'll generate non-ideal test data by creating data and adding noise. We'll find multiple instances of the template within the input image, and we'll circle all the locations that we think contain the template, and then we'll produce these plots. Let's move over to Matlab and get started. So in this tutorial, the first thing you need to do is you need to copy over your finished create circle, image filter and ZNCC functions from the last tutorial. We're going to be using all of these. We'll only be working in the main script, tutorial 7. Now again, we're not going to cover things we've covered previously. So in previous tutorials, we've covered this kind of setup code, generating fake data, adding noise to it. We're just going to deal with this, doing the object recognition. It's very similar to last tutorial, and we'll be combining that with knowledge we've learnt from a previous tutorial. And after this, we're basically ready to copy this over and almost use this directly for finding Wally. So the first thing we need to do is utilize our image filter function. So let's just use score equals image filter. If we remember how to use this properly, first of all, we give it the input image, which in this case is image underscore noise. There is a true image that doesn't have noise, but if we were pretending this is real data, we don't have access to the perfect image. We only have access to the one that's corrupted by noise. And we have our template, which is called template, and we're going to use ZNCC as a metric. And then we're just going to use contour F to plot this as we have in previous tutorials. So contour F, score, and we'll tell it to plot 20 level sets. If we run this now, I'd still like it to get rid of these ugly edges there. So we can do what we did before, edge color, none. That looks better. So now, instead of finding just the highest scoring element like we did in the previous tutorial, we want to find all elements that are above this threshold. So we've done this before for single pixels, now we're just doing it for template matching. So let's just go index equals, and we're going to use the find function to generate the indices, and then we just need the logical expression, which is, in this case, everything in score that's greater than 0.8. Now if we run this, so the 289th element, etc., these will all be elements of the similarity measure that are greater than 0.8, and they'll correspond, hopefully, to targets in our input image. But we just want to convert these indices to sub-indices so that we can find the X and the Y center for plotting a circle. So we've done this before as well. VU equals ind to sub. Remember, this converts linear indices to sub-indices. First of all, we give it the size of the matrix we're dealing with, which in this case is score. And then we give it the indices, which in this case is IDX. So now if we run this, so these linear indices should correspond to these sub-indices. So now we just need to draw our circles. So the number of circles we want to draw is equal to the length of this vector, or it's equal to the number of elements that scored above 0.8. While we're here, I made a mistake. I should not have used 0.8 there. I should have used threshold, just so that we can play around with this number later. So for I equals 1 up to the length of IDX, that's the number of circles we want to plot. Let's just use our create circle function to get the points for a circle. Now the first number here is the X center, which in this case is the ith element of U, and the Y center is the ith element of V. And let's use a radius of 2. And then we just need to plot X and Y. So if we run this, everything should be complete and working. That seems to be working. What we should do though is just make these all plot in the same color. Let's use red, so we can use R for red. Okay. Now the interesting thing now is that we've missed some. So let's inspect this and see what we've missed. Looks like we've missed these two here, so these values must not be above 0.8. Looks like they're sitting at around 0.6, 0.7. So the question is now, are we better to have false positives or false negatives? Is it worse for us to accidentally detect something that isn't there, or is it worse for us to not detect something that is there, like we have here? Well, we could play around with that by changing this number. And we can see here that we've picked up every one. We've picked up every one there. So this might be better. We can see here this one's particularly nasty, because we haven't picked up any of these, but for some reason we've picked up one here. So there's no black and white answer to what's better, false negatives or false positives. That's an engineering decision. We'll look at this again for where's Wally. We certainly don't want to miss Wally, so we might need to play around with this. We've now completed every tutorial that builds up to finding Wally, so in the next tutorial we will be automating where's Wally, using everything that we've learned in the past 7 tutorials.